towards a consensus on carbon emissions from tropical deforestation. Thank you for taking time, especially late in the day. I'm sure you're tired, but I think you'll find this an interesting discussion. I'm Mike Lesnick. I'm senior partner with the Meridian Institute, and I'm very pleased to be serving as moderator for this session and also to have been part of the neutral facilitation team that assisted these really wonderful scientists from the Woods Hole Research Center and from Winrock International. As you may know, earlier in this year, in 2012, teams of scientists from both organizations published the results of their analyses of carbon emissions from tropical deforestation in Nature Climate Change and in Science. I think it was January and June, respectively, from each organization. And there were some apparent differences in the results, which created a little bit of a stir. At that time of the Science magazine report, Dan Zarin, who is sitting to my extreme left, who is the program director from CLUA, the Climate and Land Use Alliance, a group of philanthropic foundations in the States who are very involved in REDD and land use issues. But also, maybe as importantly for this topic, a former professor of tropical forestry. In the perspectives section in Science, reflected a little bit about the article and about some of the issues associated with the analyses. He and Andreas Tvetros, who is the deputy director of the Norway International Forest and Climate Initiative, chat regularly given their missions in life. And I had some thoughts about this and the two pieces and the two analyses and just how important that information could be. They suggested in the middle of the summer of this year and asked the two science teams would they be interested in sitting down and talking through perhaps what they did, how they did it, what they found out, just to unpack this a little bit. And thankfully, really both science teams agreed to do that. Today, you will hear the results of their very intensive collaboration that started in July and pretty intensively until last week between the two teams of scientists. And today, they are releasing their policy brief that's called Progress Towards a Consensus on Carbon Emissions from Tropical Deforestation. That policy brief looks like this, and it will be available as you depart today. Please feel free to take one or more. Full report is in English. There is Spanish and French available as well. The report is now available, for download, as well as the executive summaries at forestemissions.org. So please feel free to take a look. The way we will be proceeding today, we've got quite a group, but I think you'll find this useful and interesting. I'd like to first turn to Andreas and Dan as kind of co-funders, sponsors, initial talking about this, to maybe reflect a little bit, Andreas first and Dan, about what motivated them, what was on their mind, their thoughts about this, and framing these analyses, and really this policy brief. I'll then turn to Sandra Brown from the Winrock team to spend just a few minutes putting this in his kind of historical perspective, the work that was done. We'll spend really kind of the bulk of our time with Alessandro Baccini from Woods Hole and Nancy Harris from Winrock, just to talk through with you what they did, how they pursued it, but also as they were unpacking, what were they finding out and what led them going forward. Doug Boucher from Union of Concerned Scientists is very gracious to, at times, review what was going on and would like to make some policy observations about the work that's been conducted. We may ask Andreas to say a few words before we open up again to questions, answers, discussion among all of us in the group. And before we conclude, we've asked Dan Zarin to serve as rapporteur for the group and maybe last reflection. So that's our plan. So welcome everyone, I'm glad you're here. Andreas, if we can turn to you first and then Dan, but Andreas first, some thoughts about this.
Okay, thanks. Everyone here, do you hear me in the back? Good. I mean, the Norwegian government is investing a lot in efforts to try and reduce emissions from deforestation and forest degradation. Our government has committed to spend up to 3 billion Norwegian kroner per year. It's more or less $500 million. So it's a big scale investment, and it's founded on the fact that these emissions were estimated by the IPCC to be 17.4% of global annual emissions, almost 1/5 of the emissions. And it was also identified to be one of the potential climate change mitigation opportunities on the table that were most cost efficient, that could be done at large scale and within a reasonably short time scale compared to many other solutions that need much more technological innovation, for example. Then we have been supporting a lot of activities to strengthen the knowledge on carbon gas accounting, forest cover monitoring. But we were very surprised when the science study by Winrock came up with a figure that was much lower than previously thought in terms of global emissions from deforestation. And at the same time, more or less, another study from Woods Hole with different figures, much higher. And this created a sense of uncertainty, both in our team, of course, but more importantly among our decision makers. Are we overestimating the importance of fighting climate gas emissions from forest destruction? Is the Norwegian government overselling the importance of their investment? And these were questions that were raised in Norway in media. So we found out that it would be very valuable to see if we could find the reasons for the difference in numbers, to see if they were caused by different methodologies, different definitions, or simply by the fact that our data was too weak. We were very happy that Dan Sarin came up with a proposal to see if we could get these groups to sit together and try and find all the reasons and explain where the gaps are, where the differences in methodologies were. I'm very thankful to Dan for proposing that to us. Even more thankful to the scientists from Winrock and Woods Hole that agreed to do the work. I know it has been a lot of work in a very short time frame, methodologically and scientifically challenging. I'm impressed by what you have been able to do in a very short time frame, and the Norwegian Climate and Forest Initiative wants to underline the value of what you have done. And of course, at this time, it's huge thanks are due also to the Meridian Institute for the work that they have done in facilitating this process. I think that this kind of collaboration between scientific institutions working on the same topic, but perhaps working from different angles and with different methodologies, is the way forward. I mean, the brain power working on this is badly needed, and the more you compete but also cooperate, the faster we will get to improve knowledge. So I think this is a very good example of things we need to see more of in the future. Now, I really look forward to your results that will be presented now, and to your continued work. Thank you.
Thanks, Andreas. Not only powerful brain power, but intimidating at times, I might add. Dan Zara, speaking of which, would you talk a little bit about getting this launched and just maybe how this fits?
Sure. I'm just using the podium because this group is so large that they've run out of microphones, so I stand up here. Thanks, Mike. I thought I'd talk for a few minutes really about why we are here, why this group is here, why we've invested, all of us, in this process. And it boils down, I think, to two things. One is urgency, the urgency of the climate crisis that we are in right now. And the second is the realization, and maybe since this is a scientific panel, I'll just call this a hypothesis, that science matters, and that it matters to policymakers. Andreas has already indicated that in a small and relatively unique place called Norway, that seems to be the case. I would posit that it has importance more broadly, even in this strange political venue that we're on the margins of here, because science, in an almost simplistic sense, in this context, either provides policymakers with clarity or it confuses them. And when it confuses them, it provides them with one more reason to do nothing. And from our perspective, that's something we really, truly want to avoid. The second point or the first point on urgency, well, so I think it's become increasingly apparent to all of us, in the big picture, we're losing. We are losing on climate change mitigation. We have a clearly articulated goal by policymakers in this very venue a few years ago of limiting the global climate change to a maximum 2 degrees. We have issued just a couple of days ago the update of UNEP's report on the emission gap between the trajectory we need to be on to achieve that and the 450 part per million CO2 concentration in the atmosphere associated with it by 2020, and the path that we're on. And it's growing. Not only are we losing, but we're accelerating the rate at which we are losing. And this constitutes, and I mentioned to a couple of you I've run into separately that I've been feeling very pessimistic. But I think if we look even objectively at what the purpose is of the intergovernmental exercise happening here, the ultimate objective of which, as stated in Article 2 of the Convention, is to achieve stabilization of greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system. Now, policymakers have decided that is this 450 ppm concentration. The science indicates that with that, we have a 50% chance of avoiding catastrophic consequences, and we're not meeting it. So we're not doing well. We're not doing well broadly in the big picture, and one place, as Andreas indicated, where it looks like we might be doing better is with mitigation associated with REDD+. If we look across the board now on how we're doing on REDD+, it's kind of mixed. We're not really too sure. It's fairly apparent that in Brazil, or certainly in the Brazilian Amazon, which has been a major part of the problem globally, that we're doing really well. Or I should say the Brazilians are doing really quite well in that space, and having announced just a few days ago that we're at the lowest rate of deforestation in the Amazon on record, and the record now is a 15-year record. No, it's a 25-year record, pardon me, a 25-year record. So that's the good news. The good news on REDD+, or a big chunk of it. In Indonesia, the other largest source of emissions from the forests, from deforestation. How are we doing? Well, truth is we don't know. too well how we're doing. What does that do for policymakers? Well, it certainly doesn't give clarity. It gives a great deal of confusion. So we entered into a process of exploring with those two groups whether they would be interested in trying to address that. There was no effort here to try to make everybody agree, but rather to see if we could all understand what those differences were at a rather sufficiently deep level that they could be explained to everyone. And I'm very pleased to say that we've gotten there. These two groups have worked very hard. They've really undertaken what is, to be honest, not they've undertaken an unusual process in the sense that it's been quite accelerated and quite intense. It's not at all unusual in the scientific community that we have two or more groups working on the same thing, come up with somewhat different results, and over the course of time they kind of figure out, well, who was right or wrong about which part of that, you get to new numbers and so on, and this is the way science progresses. But because of the urgency of this work, in collaboration with Norway's International Climate and Forest Initiative, we thought it would be useful to encourage this process of accelerating the work that they did. So they've done that. And so we now have, and they'll talk about this, we now have a benchmark. We have a benchmark for a historic benchmark, objectively derived. It's a benchmark that these two groups will be happy to talk about with you, and that can be carried forward. This is important for a couple of really reasons. Really important reasons. One, it'll be very useful to see, to measure progress against this benchmark going forward at the global level. The other is that we have a number of rather vaguely defined targets by, in some cases by international bodies like the European Union, or by non-governmental organizations, or by corporate associations to reduce global deforestation by X. Usually, from the ones I've heard, most of that X is by 1/2, and by 1/2 by 2020. But there's been no benchmark for that target setting, and we need this benchmark to be able to look at, to hold those targets to the test. The last point I'll make is it's quite important in the context that we're in here to point out that the focus of this analysis has been on the first D of deforestation. And that first D is a critical part. It's a big chunk, but it's important for us to remember that that's not the entire story of what REDD+ is trying to address. Second D, degradation, is quite challenging, and we've had some discussion about that in earlier sessions. And a bit beyond the scope of this analysis, they've included some discussion of what that means. But in addition to that, we also have a big contribution from peatland emissions, and that remains somewhat uncertain. And we have a contribution from mineral soils associated with land use change as well. And you'll hear more about all these details from the two groups, and I'm very pleased that we've arrived at this point. It's been a really fascinating process. I've been really encouraged by hearing how seriously they've been questioning not only each other in their interactions about the assumptions that one group or another has made, but you know this process is working when people within the same group turn to each other and say, well, let's go over how we did that again, to be sure that to questioning each other and really bringing out this whole process with the idea of getting the best science and the best results that we can at this time, recognizing that it moves forward. And where we are now will be at another place a few years from now as work continues. Thank you very much.
Thanks, Dan. Thank you, Dan. We may not have gotten you a comfy chair, but we gave you a podium. So, all right, let's get into this. Sandra Brown from Winrock. You see the bios in the program, so we don't need to do that. But Sandra, it would be helpful, I think, to talk a little bit about some of the history, the science background for this before we dive into what was done by each team and jointly. So if you don't mind, can you give a little historical perspective from the science side of this?
Thank you, Mike. Well, as many of you are aware, this topic of what are the emissions from tropical deforestation has been studied for many years. And myself, and with Ski Houghton, who essentially leads the Woods Hole Research Center team, he and I have been funded for this kind of work since the early 80s. And in those days, we were rather limited in what we had available. We had to depend, for instance, upon the FAO data for rates of change of forest cover. We would compile and synthesize the published literature on carbon stocks of tropical forests. I remember in those days, we used to say, well, the carbon stock of tropical forests is X, and that was based on about 30 hectares that had actually been measured at that time. So we have come quite a way. Through time, we started to find out that there was all these forest inventories that have been mentioned at various times. We talk about forest inventories now for going forward, but there are lots of forest inventories out there, and I thought, well, look at all this. This is, hundreds of hectares being sampled here. Maybe there's a way to convert inventory data to biomass, and so that kind of came along with, the biomass expansion factor concept. And then you start to see in the FAO reports now, and people estimate how much biomass they have in their forests in addition to carbon. And how we put this together at the time, we didn't have the benefits of IPCC. The IPCC greenhouse gas emission inventory, the first guidelines really widely available, came out in 1996, and we were doing this work in the 80s into the 90s. We were, both of us, Ski Houghton and myself, my team, we were both supported by the United States Department of Energy because they wanted to know, unfortunately we haven't followed through as well as we perhaps could have done, but they wanted to know back then where were the sources of CO2 coming from, because they felt that eventually they're going to have to regulate emission sources of CO2. And at that time, it was thought there was a significant amount came from tropical deforestation. Anyway, so Ski Houghton and his team, they went off and did their thing, and we went off and did our thing. And as scientists, numbers come up and you discuss them and disagree with each other, but you move forward, and the US Department of Energy forced us to work together. And it was then we started to say, well, look, really the only way to make progress in this area, to come up with numbers that have more credibility and more reliability and less uncertainty, is to start to try and map forest cover change and forest carbon stocks and co-locate them. So you could actually say these forests have this carbon stock in a map form. So we did start to develop carbon maps, but now we have more sophisticated ones. So both studies, Woods Hole Group, they have a carbon map based on LiDAR and other remote sensing products and ground data. The map that we use now by Sasan Sachi, the same kind of approach. So we have more sophisticated maps, higher resolution, and we now are starting to have the remote sensing products. For years, we didn't have the availability of pan-tropical remote sensing at a reasonable scale that we could work with. Now we do. And if you put the next slide up, both groups used carbon maps and they used remote sensing for their change. And yet, we reported in the Harris paper these results that suggest large differences. So this is really what started it. And as Nancy and Ali will show in their discussions from now, actually how we are much closer than we appear to be in this graph here. So if I may turn it over, Mike, to Nancy.
Perfect, Sandra, thank you so much. Okay. Let's talk a little bit with Alessandro Baccini. So this is the Baccini et al. Paper that was in January, Nature Climate Change. And also at the same time, a little bit on and off here with Nancy Harris, from Harris et al. In Science from June, right? So the way we'll tackle this is first, an understanding what happened in those papers, what was motivating them, the kind of work they did, and then we'll talk about the collaboration, right? So, Ali, we'll start with you, if that's all right. So
Thank you, Mike.
can you just say a little bit about an overview of the Woods Hole approach, what you were trying to get at, the kind of approach, the means you used, et cetera, just to give the group a bit of a sense.
Great. I will be happy to very briefly explain why we started to do this work at the center. As many of you might know, there are two main variables that determine the amount of carbon emissions derived from land use and land use change. We have what they call emission factors, that is the amount of carbon stock that is stored in the vegetation in the forest, and the amount of carbon that is stored in the land that is replacing the forest after is removed, and as well as the other important element is the activity data, so the rates of deforestation and degradation that we have to take into account. Studies in the past identified that large uncertainties in the emissions from tropical deforestation are in part due to large uncertainties in the carbon density estimate that were available for carbon emissions analysis. So at the center, as part of a 3-year project sponsored by Moore, Google, and Packard, we generated what was the first 500-meter spatial resolution carbon stock map for the entire pantropical belt. And having this new data set in mind, we were very much interested in updating the record of emissions from land use and land use change that were published in the past. So our main motivation really was to update the record of net and gross emissions for the pantropics. We were not really focused on specific national level assessment or any country. So how did we do that, right? Well,
maybe also where you found challenges in doing that and what you thought were particularly interesting and successful too.
Yes,
Great.
I will be happy to describe how difficult it was as we move a little bit forward. So the first big challenge for us was, of course, to come up with a pantropical carbon data set, right, that covers the entire tropical belt. And this was possible thanks to a combination of field data, LiDAR data, and MODIS observation that they were freely available for the tropics. So what I would like to mention also that this project of the mapping the carbon stock was also possible thanks to the collaboration with many indigenous groups, especially in South America. And this gave us the opportunity to actually explore and take sort of the advantage of working with local communities. So we were able to join country capacity building with the science, and that was very exciting. So we had this carbon data set for the tropics, and now the point was, well, okay, we need to combine this with deforestation. We need now to have a good way to say, well, what was the biomass of the forest that is lost? As Sandra said, in order to improve our estimate of carbon emission, the best way to do it really is to combine the emission factor with the activity data in a spatial way. Well, we didn't directly do this. What we did is that we took maps of deforestation to identify the location where the deforestation is happening. And then based on this, we use a weighted area average approach to sort of better characterize the biomass of the forest that was lost. After that, in order to sort of be consistent with previous estimates of emission, gross and net emission for the tropic, such as CLUA and PAN, we use the rate of deforestation from the Food and Agriculture Organization, FAO. And we use all this data set now in a bookkeeping model that keep tracks of the changes in carbon stock, right, over time, and we did the analysis for the years from 2000 to 2010. Now, what is a bookkeeping model? Many of you might know or not, but a bookkeeping model is really a simple accounting system that allow you to track the changes in carbon stock at the hectare per annual carbon stock changes at the hectare level. And how does it work? Well, it keeps tracks of the changes in carbon when forest is removed for the cropland, when forest is removed for shifting cultivation, when forest is removed for pasture, and as well as take into consideration when cropland is abandoned and forest is coming back. Okay, so here we have the opportunity to account both for the sink factor and the source factor in the emissions. Our study indicate that the net emissions for the pantropic was about 1 petagram of carbon per year, and the gross emissions, so without considering the absorption from the regrowth forest, was about 2.2 petagrams of carbon per year. Now, here it is important to, again, to stress the fact that this gross emissions, 2.2, is not only from only from the deforestation, but here the deforestation includes all the activity that I already mentioned. So it's not only deforestation, but it is shifting cultivation, right, and harvesting and logging. Okay, in one way you can think at the second D of red. Okay. Yeah, and so I think this is sort of the main result of our study, and that this result then was used from NICFI to sort of address the difference with air work. So I will
we'll come back. Nancy, can you talk a little bit about the approach Winrock used that we saw in Science Magazine this summer?
Sure.
And what you found?
Well, as Sandra pointed out, she's been involved in this since the beginning, so it's nothing new. But this work specifically came about a couple of years ago when the World Bank was developing they develop an annual World Development Report, and each year that report focuses on one specific aspect of development. And so the 2010 report that we contributed to was on development in a changing climate. And so as part of that work, the WDR team commissioned a bunch of research activities related to both the technical and policy aspects of climate change. And one of these activities was related to emissions from land use and land use change, and with a particular focus on forests and the role of forests in the global climate. So prior to the work that we did for the WDR, as Sandra mentioned, terrestrial sources and sinks of carbon across large regions were estimated primarily using National Forest Inventory data and coarse level data sets, because that's really all that was available. And so for various reasons, the WDR team wanted to kind of push the envelope a little bit and say, okay, can we do better than this? There are new technologies, there are new satellites going up, and they really wanted us to move more towards the goal of matching the carbon stocks with the activity data in a way that had not been done before. And so that was really the focus of our work. The advantage of doing a spatial approximation of emissions is really so that policymakers can focus on specific aspects and specific locations of where emissions are occurring that were not really possible before. It's good for prioritizing red interventions, it's good for prioritizing funding allocation. Let's put the funding where the emissions are highest. So our approach was really to kind of sharpen the picture, the overall picture of emissions from deforestation. So if you think of a map of emissions across the tropics, it was pretty fuzzy before, right? And so the advantage of the spatial approach is to really pixelate that image and get more detail and be able to tell where the emissions are happening in a much greater level of detail. And so what we did was the forest loss product that Matt Hansen had developed was available. The forest carbon stock map that Sasan Sachi developed was available. And what our group did, I mean, they were involved in our group, but we combined those data sources together to develop an internally consistent, spatially explicit, and uncertainty, bounded estimate of tropical emissions from deforestation. So I guess the main challenge that we had as part of that work is perhaps our overambition. We went into this research thinking that we were going to do everything. We were going to include biomass, we were going to include soil, we were going to include deforestation and degradation sources, and we did attempt to tackle all of those things, and it quickly became apparent that we just didn't have any confidence in the data for soils and the data for degradation logging things, and so we decided to kind of change the focus a little bit and say, what do we have confidence in? How can we improve the estimates of what the data are there for? And that's kind of why we stuck with deforestation only. And so the result of that, the success of that work was really, for the first time, we have this spatial estimate, spatial benchmark of historic emissions that hadn't really existed before. And what that turned out to be was 0.8 petagrams of carbon per year, or those of you who think in gigatons of CO2, it's about 3 gigatons of CO2 per year. And so we compared that with Ali's paper, and we said, okay, well, we're focusing on gross emissions from deforestation. What's the most comparable number that we can get out of their paper that we can compare our number with? And the differences that I'll get into in a little bit about the two analyses made that a little bit challenging to get the exact right number because our approaches were different. So I guess I can get into the differences now.
Yeah, let's go forward now. Starting in July, the team started to meet and unpack what was going on. Can you describe for colleagues here, how did you all approach this together?
Yeah.
And what were some of the differences you found between the two approaches, and what did we learn along that path so far?
Okay. So as Dan mentioned, NICFI and CLUA kind of pushed us into a room together in DC for 2 days and said, you guys duke it out, figure it out, what are the differences? And, as some of you know, the people up here, it was a very animated discussion at times. The minds and the personalities in that room were fun to work with and be a part of. So, those 2 days were really a good opportunity for us to revisit what we had done for our own paper, because once you publish it, you're just like, okay, moving on. And so revisiting what we had done ourselves, and also kind of dissecting what the other group had done in their analysis to try to understand better what the differences were. And the conclusion of that 2-day meeting was that there were 4 main differences that resulted in these 2 different estimates. The scope of the 2 analysis, that's the first difference, and kind of determines the other 3 differences. So the different scopes determined the different scales of the two analyses, the different data sets used, and the different models used. So the different scopes, we have a slide here. Our analysis, as we point out clearly on our paper, only focuses on that first D. And the Baccini et al. Paper focuses on more than just deforestation. This slide, which is included in the policy brief that is available later, shows that those stacked bars, we have gross emissions, or positive emissions on the positive side, and removals of carbon on the negative y-axis. And so Ali's paper included a lot more than we did. So the goals of the two analyses were really kind of different. Our goal was the spatial estimate of deforestation. Their goal was to update the record of net emissions. Okay. And then the second difference was the scale. So our analyses wanted different things. We had different goals. And so our spatial analysis was completed at the 18.5 kilometer pixel scale. So we had lots of different pixels of where deforestation was occurring, how much carbon was in there. The Baccini analysis uses the Houghton bookkeeping approach, which is not spatial. It operates at the regional level, and so although there were remote sensing derived estimates, those estimates were fed into the regional bookkeeping model. The third difference was the data used, also due to the different scopes of the two analyses. Our estimate, we wanted a spatial estimate, so the data that we used was by nature spatial. We used remote sensing data to get at both the area term and the carbon stock term. The area data that was used by Baccini was derived from the FAO data, forest resource assessments. The carbon stock maps in the two analyses were different, derived using similar methods, but there are some differences that caused differences in the resulting emissions estimates that Ali will go into a little bit later. And then the final difference, there are differences in the carbon models we used. We took a very basic, simple approach of estimating emissions as area times carbon stocks equals emissions. That was our model. The bookkeeping model is a little bit more sophisticated, is more involved than that. It's developed as a series of response curves, and there are assumptions and parameters used to define those response curves for different regions. So the initial carbon stocks matter, but the response of land use change, the response of the land to that land use change is also important. So there are legacy emissions occurring, there are emissions that are delayed for future years. It's much more of a time sensitive model. So as a result of those differences, we got different numbers. And so I guess Ali will talk about what we agree on.
All right, Ali? So so you learned what the differences were between you. Can you tell the group here about, so how did you find out where you agreed and why? How did you get to that point? And maybe some implications for REDD+ monitoring?
Okay.
And I've got one more for you after that.
Okay. Well, I think I have an easy job to say where we agree, in the sense that.
And how did you know you agreed? All right.
How did we know that we agree? Right. So, well, so after working with the WinRock team, and we really had to work hard at a very fast pace in the last couple of months to be able to be here and have some results. So what we really understood is that the main issues, the main difference that was reported in the science paper was sort of the result of a definition issue. And so when we understood that, everything was sort of much easier, and especially if we looked at the number at the pantropical scale, it was easy after we reconciliate our analysis for the period 2000-2005, because our original work was for 2000-2010, and because the deforestation rate sort of changed between 2005 or 2010. After we take care of that and some areas in the analysis that we didn't cover or they covered. Well, so the final funding showed that actually at the pantropical scale the two analyses converge. And so as you can see from the figure here up on the screen, if we look at the deforestation only as an absolute term, so there is no degradation, no harvesting, only the deforestation, it's amazing that two independent studies using independent data, different data and different approach actually come up with a converging number. So that in one way should give confidence to Andrea that at least at the pantropical scale the role of forest and deforestation is still very much important. And so I think that was a great output of this work. But also I would like to point out that when we look at specific regions, well, we do observe some disagreement in the values both of carbon stock, emissions, and deforestation. So these analysis now at the subtropical scale, so at the continental scale and at the national level, is sort of under investigation. The project is not over yet, and so we are looking more in depth to see why exactly this is happening. Okay, but overall, especially at the pantropical scale, we are confident that we reach an agreement on the number of 0.8 petagrams of carbon per year in gross emissions from deforestation. And this is, I think, is the first time that actually two groups agree on a number, and so now policy makers should be quite confident to have a target to work with. So if they want to decrease the emissions of 50%, now they have two groups that they agree that if they can go down to 0.4 petagrams of carbon per year, that is the target that we should think of. So,
but, Ali, before we move on to the policy things, Dan Zarin always reminds me, science is always trying to make progress. Keep questioning things, what's needed. Just a word or two, maybe, about what still needs to be addressed. What would be useful to have? How do we keep progressing on this before we turn to Doug and policy issues?
Right. Well, I definitely agree with Nancy when she said that they prefer to stop to the deforestation and not actually extend the analysis to the other pools, because working with the other pools you need to be willing to introduce quite a large uncertainties on your estimates, because those other pools are less known, in the sense that we very well know that it has been much more challenging to come up with estimate of degradation or harvesting, or the amount of soil that is stored in the soil, than just limit our analysis to the deforestation. Okay. And so in terms of science, I think that what the two studies are showing is that we have two methodologies there that are quite solid, and they can be used to estimate the emissions from land use and land use change. And what is now maybe required is that we start to look more in details in the pools that we don't know as well as the deforestation. And so yeah, I think that this is one of my comment, and I'm happy to hear from Nancy and Sandra.
Yeah, I think Ali has a good point that we need to improve the data availability for sources of degradation such as timber harvesting and so on, but also for the soil carbon pool. The reason that we didn't include it is that there are very few data sets that are available at the spatial level of spatial resolution that biomass data are available for. And so improved soil carbon data sets would allow us to include that with greater certainty. Sandra, do you have anything to add?
And we could get agreement among the scientists that we could use the same methodology. We did look at, when you read the policy brief, you will see that there is, we talk about how they compare when you include soil, and we explain why we come up with a different answer. So the more things you add to this analysis, as long as you keep it in the vegetation and you keep it for the same time period in the same geographical region, we do well. But you start to add other pools like soil, we start to diverge. The other thing I would support what Nancy said and Ali both was on the soil. There is a harmonized soil carbon map out there, which is what we used, and we use the IPCC soil methodology. But if we really want to improve on that, something has to be done. I mean, there's a lot of people who now have collected more soil carbon, so a concerted effort to try and update the harmonized soil carbon map with real data that's being collected out there in some methodology, some approach would be really good, and remapping it. Thank you.
Great, thank you all. Dan, quickly, to the podium.
Quickly, I just wanted to reflect a little bit on this question of the really important stuff that needs to be done next. Sandra, in her introductory comments, pointed out the sort of history of development of this work. And I think we're kind of with the degradation issue, we're at a point that's kind of like that earlier history where we were with deforestation. We have in the literature now really excellent analyses of degradation and for smaller areas. But some of them are getting bigger. And when we started work on deforestation, it was at smaller areas and building out from that. That process can be accelerated so that not so long from now, we could have this data on degradation. It's already available for some regions in particular countries and being put to use. The question is, how quickly can that be scaled up to the global level? And for peat, which is the other really big important part, we're almost there in terms of having a sufficient scope for having greater confidence in the peat emission numbers because they're not spread across the whole tropical region. They're concentrated in particular geographies. So although there is more work to be done on these particular issues, I just want to stress that we're not that far away from actually having the work that needs to be done. And it's a bit beyond the scope of what the analyses these guys did, but it should not prevent progress in the policy arena because we are making big progress as a science community in this, and it's becoming policy relevant very quickly.
Thanks, Dan. Doug, you're a scientist. You're involved in the policy world. In some ways, you're our simultaneous translator, maybe for this session. A few thoughts from you, especially of how does this relate to the policy world?
Yes, and as Mike said, I am speaking to this sort of from the policy side. I am a scientist. I work for the Union of Concerned Scientists, and when I read the science, I was concerned. The differences that Dan has delineated, the possible effects on negotiators of seeing a lack of clarity, of seeing a confusion, clearly was something that could set this back. And if I can summarize sort of where we've gotten to now and the lesson that policymakers should take out of this, I can sort of hark back to a session we were in this morning when we noticed that a lot of the important words that related to the session started with the letter D: drivers, deforestation, degradation. So I might say that for this result, the major words, many of them start with the letter C. And that is that the policymakers were having conversations about carbon and climate change, but there was confusion instead of clarity, and that was a concern. But now they have numbers that are comparable, they've reached consensus, and we can be confident again. I might mention, I was tempted to talk about the UNFCCC and its conferences in Copenhagen and in Cancun and currently in Qatar, but I thought that would be going too far, so I won't continue.
You think it's been easy with this group, right?
Let me also say, a simpler way of putting it this is, in order to reduce deforestation by any amount, you have to have a starting number. You can't say we're going to reduce it by half, but we don't know half of what. And for policymakers, that's important. And what I think the two teams have told them now is we agree on a number, and that number is 3 gigatons of CO2 annually on a global scale. And the final thing I would point out, and I think this is really important for the interface of science and policy, is that this is a number from a decade ago. This is not the number for today. This is from the period from 2000 to 2005. And so one of the things that the scientists can start doing, and I think relatively speedily, is to ask just how far have we come since then? How successful has REDD+ been? How much have emissions been reduced in the last decade? Dan pointed to the major decreases in Brazil. Aguiar and colleagues have estimated those as being somewhere between 0.5 and 1 gigaton of CO2 per year. So it's very, very substantial. And now we can have scientific numbers that not only say what was our starting point, but can tell us how far along are we on the road to success in cutting deforestation in half and eventually to 0.
Thanks, Doug. Friends in the room, bear with us one more moment. We're going to come to some questions and discussion, but Andreas, maybe come back to you since you started us off, maybe some reflections about what do you see this meaning?
Well, I do think that, the confusion that was caused has been calmed to a large extent, and that is very important, very positive, because decision makers need clarity. And clarity now on emissions from deforestation, on the number 3, is important. But it's also important to keep in mind that the IPCC figure in its last assessment report was that land use change, including forestry, was 5.8 gigatons. So it still sounds like a reduction. So it's very important it's not really on the screen, but to keep attention on the fact that all the other pools, degradation, the soil, are not included in the number 3. And in your paper, you indicate that you estimate them to be of the same, more or less the same size. Right. Which means that the relevance of REDD and measures to reduce emissions from forests, but also peatlands, of course, is as high or possibly higher than we previously thought. And keeping a focus on reducing those emissions is going to be key if we're going to achieve the 2 degrees target that we have to achieve if we want to have a good planet in the future. Another important point, very linked to this, of course, is the fact that we need to continue researching, improving our knowledge, particularly into those other pools. Getting better data on degradation and soil, of course, is going to be key for our future work. And I do think that investments into national level monitoring, reporting systems are key if we're going to work on those pools. But I mean, thank you again for the clarity that you have been able to produce. It is valuable. And from the Norwegian side, I want to indicate that we will, this is important, we will continue working on REDD at the same level as we have done until now. And this is an important basis for that work. Thank you.
Great. Thank you, panel. Okay, friends, questions, comments you've got. If you wouldn't mind identifying yourself, and if it's directed towards a particular individual, please do that. In the middle, Fred, is that you? Could you stand up? Maybe that, or do we have a microphone? Great.
Fred Stoll from the World Resource Institute, and thanks for this panel, very enlightening. I'm a geographer, so that's from the simple kind. And so, as you look at where deforestation is, and then you multiply it by a carbon factor. And so I wonder, why would you make it yourself more difficult to do the bookkeeping methods? Because it seems like the simplest direct measure you have is somewhere is a deforestation, and you multiply that with your carbon number. That's one question. The other question is that, we all like the FAO because it was the only one, the FRA, for the last 20 years to come up with forest deforestation numbers. But we also all know the weaknesses of the FRA in many forms, in areas, and how they were made in different countries. So I'm actually surprised if you use FAO numbers that you come to the same number as if you use other numbers. And so because I think the FAO numbers are not, as we know, very accurate. And so why would you use the FAO numbers? That will be my question.
Thanks. I think someone right behind you or next to you had a question. All right, stand right there. Fine. Pass it there. Stand up and introduce yourself in the question.
Martin Harrow from Wageningen University, and just to follow on that one, and it's good to see the consensus, but I think it's very important. And sometimes if you aggregate things add up and uncertainties are reduced. But what struck me a bit is the large difference between Africa and Southeast Asia, and kind of wonder me if you get the right answer for the wrong reasons a bit, or unless you can explain a bit why they are so different. So I know it's not an easy one to beat on, so I'm not going to put you on the spot, but maybe you have an explanation a bit more.
Great, thank you. All right, let's go right behind as long as we make it easy. Then we'll come to the front on this other side, sir, after this one. And thank you for being so to the point in your questions. It's helpful, I think, for those trying to respond. Please.
Thank you very much to the panel and to the organizers. I think it's extremely useful information. I wonder, though, if I see that if we scale down the analysis to regions, and probably if we were to scale it down to countries, the uncertainties or the discrepancies between the two analyses would be still relatively large. And I wondered your views or advice if you were responsible for developing an assessment, a periodic assessment of carbon in a country, whether you will put more efforts, or whether you will prioritize collecting data relevant to activity data or relevant to emission factors, and what will be the most urgent domain for efforts?
Great, thanks. Can we come all the way to the front on this side, if you don't mind? I don't know if there's a second microphone, or we'll just give you good exercise today. Please.
Hi, thanks. Greg Fishbein with the Nature Conservancy. Great panel. My question is coming back to Andreas's original point about IPC estimating 17%, and the sort of shorthand number that a lot of constituencies clamor for is, well, what percent of total emissions is it? And it seems like a little bit of a conundrum, because if you go with the more reliable conservative number of 3, I think you're probably under 10% if I remember the numbers. But if you go with the higher number, it's more like 15 or so. And I know, Doug, you've done a lot of good work on thinking about this, and how do we handle the messaging around the percent number, which in the end is what large numbers of constituencies are going to focus on, and not these detailed graphs. So I'd be interested in your thoughts on how we think about messaging the results of your work going forward on that question.
Great question. Let's get some responses to that, then we'll do another round. So I think the first two had to do with, so why the bookkeeping method, and what the story with the FAO data. So Ali, probably first to you about the bookkeeping method, yeah? Microphone.
Yes. So why should you use or should not use the bookkeeping model? Well, I wish Ski Autumn would be here. I'm sure he would have a long list of items to point to, but unfortunately he's not here. So I will try to do my best job in answering this question. And what I will say is that, you can consider the bookkeeping method as a tool that will actually give you sort of more flexibility in gaining more understanding on what is affecting your total carbon emissions, and especially from a temporal point of view, because with the bookkeeping model, you can move backward and forward. So you can actually project your emissions based on policy that you might think to implement. So for a country, for a government, it will be interesting to see if increasing the logging, decreasing the harvesting, or changing policy in 100 years, how this would result in the emission. And especially because if you do use the bookkeeping model, you don't have to make the assumption that all the carbon that is removed is going to be released into the atmosphere immediately. But the bookkeeping model gives you the opportunity to release the carbon depending on the different pools at different time. So you have the opportunity to actually consider the legacy of the land use change. So what happened in the past is what happened in the past. The deforestation that happened 20 years ago, probably some of that carbon is not still in the atmosphere, but it is stored in some of the pool, depending on the use of the timber that was done. So in one way, I see the bookkeeping model as a sort of flexible tool. Now, of course, the uncertainty that you will have to deal with are contingent to the quality of the data that you have to use in the bookkeeping model. But we are seeing that for some countries, actually more and more high quality data are becoming available. And also, the bookkeeping model works at any scale. So, you don't have to work with the bookkeeping model at the scale of the country. You can work at the bookkeeping model at the resolution that you want, but again, it is contingent to the resolution and availability of the data.
Ali, what about the FAO data?
This was a long answer, maybe,
No,
but
that's good.
Yeah, but a simple thing though, what he said, deforestation, even Ski's model bookkeeping model just does it that way, basically. I mean, there's some legacy, but I mean, for simple, but you can't do all these other changes with, as easily with A times B.
And what about the question about the FAO data? I think maybe Fred asked.
Yeah, so the question about the FAO data is interesting, and sort of, I think, our understanding for now is also why when we aggregate, we actually get to the same number, is because most of the emissions are driven by few countries. And especially if we look, for example, at South America, I mean, the emissions from South America are driven by Brazil. And Brazil is using satellite data, right? And they are reporting to FAO the result from their satellite data assessment. So we pretty much use the same data, right? And they have such a large number for emissions that is sort of has a big weight in the average value. So I think that, but if we do look at small countries, we definitely see a big difference.
Thanks, Ali. Before we continue, I've got these others. Maria, can you guide us? We started a little bit late, I think. How can we keep going a little bit? You'll wave at me when we're getting fine. So now we had another group of questions that I believe had to do with differences around Africa and Asia. And then also, I don't know if you see this linked or not, is about advice about if you're working at the country level, the kind of methods. Who's good to start? You want to do the country one? Do you want to do the Africa, Asia?
I can do it, yeah.
Okay,
I
great.
mean, the Africa-Asia thing is related to Ali's previous point. We have differences in Africa and Asia, but the flip side of that is, why is Latin America so similar?
Right.
And the reason to that is because the FAO data and the satellite data that we use are very similar for Brazil, which is driving at least half of the emissions pantropically. And so the differences in Asia and Africa are due to these different data sources for the activity data. If you look at the table up here, the middle kind of set of rows looks at the rates of gross forest loss, and so we have very substantial differences in those numbers for Africa and Asia. But the top row, we also have pretty substantial differences in the average carbon stocks of those two regions. And so when we look at the average carbon stocks, the maps between Ali's map and Sasan's map, those are similar enough at the pan-tropical scale, but when you start looking in and honing into the carbon stocks of the average, of the deforested areas, we get very different results.
Great.
So,
Thanks.
I mean, combining all of that, you get different answers.
How
So,
about the-
so obviously that's something we're going to pursue, why this is happening. Okay, you asked about advice on where to focus priorities on emission factors or activity data. Well, I guess I would say you have to focus on both if you want a good result. You know, they're done by different teams. I mean, you know, the remote sensing is for your activity data, and so that's one set of expertise, and often, you know, they can work. And then you know, the ground data, well, it depends on how variable your country is, you know, how disaggregated the forests are, whether you have to go a long way to get to the forest. And there's a whole variety of factors that influence cost. And so I really could not advise you in general, as a general rule of thumb even, to say which one to focus on first. I mean, they're both needed, and they're both needed to a high degree of accuracy if you're going to have a reliable answer. So that's the best I can do.
Good. Nancy, did you want to say something?
Yeah, I just wanted to echo Sandra's point, but also the numbers that we report at the pan-tropical scale, those aren't the best numbers for the country scale. It's easy to improve those forest area loss numbers at the country scale by using higher resolution data. And so we're not suggesting that these country level estimates that we're presenting in our paper are, you know, the numbers countries should use. There are definite ways of improving the forest loss term relatively straightforwardly.
Maybe Doug, I think one of the last question in this cycle had to do with kind of messaging around this and the numbers and.
Yeah, and Greg pointed this out that you know, we very often talk about these in terms of percentages, and that the UNFCCC has talked about it, the IPCC has talked about it in terms of percentages, and something like 15, 17, sometimes even 20% of global emissions. And he's right that if you do the division for the years 2000 to 2005, which was a period when global emissions were lower than they are today, fossil fuel emissions were lower, you do get a number that's just about 10%. Alessandro did the division. That, however, of course, leaves out important emissions that are not as well estimated, but clearly are there. It leaves out the soil, it leaves out the peat. On the other hand, you can't just add that all that emission, the total from everything else to the 3.0, add 2.3 to 3.0. And it's not only because there's a lot more uncertainty about it, although that's a good reason. It's also because at least part of those emissions are part of cycles that are related to removals from the atmosphere. Shifting cultivation is the best example from that, where if the shifting cultivators don't cut down the forest doesn't grow back in the next cycle and then get cut down again and then grow back again. So you can't simply add them together. It's to use a sort of a tropical version of the common metaphor, it's like adding mangoes to pineapples. So those are areas where I think we're going to have, you know, considerable more research and considerable more discussion about what's the best way to express this, and I think expressing it in terms of gigatons of CO2 per year, as the two teams have done, is for the time being the best way to look at it.
Thanks. Andres, did you want to come in on one of these?
Yeah, I'd like to comment shortly also on the question on how to communicate this, because that's obviously important. I think it would be wise to focus on the fact that this is the deforestation part of the puzzle, that the paper indicates that the other degradation and also the soil emissions are of possibly the same size, but that hasn't been really the focus of this paper. But there are many other works looking at peat and other soil emissions, and the IPCC's next report scheduled for next year is probably going to, or hopefully at least, going to give us more authoritative figures on those emissions. But I would like to raise one additional point when it comes to the importance of this for policy. Yeah. equally important to knowledge of the size of
Thank you.
red emissions or forestry-related emissions to the climate change problem. Equally, or perhaps even more important to that, is knowledge on how much can red be of the solution. How many percentages of the emission reductions we need before 2020 can be delivered by red? And to do that, we need knowledge of the emissions, but we also need knowledge on the time factor, how fast can emission reductions be achieved. And there have been studies on that indicating that red could deliver somewhere around 30–40% of the emission reductions we need in the short term, because it is possible to do red in a relatively short term. And that is an important message to decision makers, though not directly related to this paper.
All right, Maria, thank you. So we need to conclude by 1740. Let's take a couple of more questions, then Dan will look to you as rapporteur to close us up. Way in the back with the paper holding up.
Thank you.
Oh no, Jim Penman.
Oh, no.
Hi, Jim.
I have three observations. I mean, of course, maybe you've said this, but it's worth saying again. The IPCC's 17.4 was never just a D number. It was always with associated land use change. I think it's in the third assessment report. It's worth just reminding ourselves of that point. I think the presentation was extremely interesting. I would have liked a bit more clarity on what the negatives actually mean, because I think that's quite important in policy terms. Are the negatives from industrial logging sort of accumulations of carbon in industrial products? I mean, maybe they are. What part of the negatives is associated with land use change, of course? I mean, because, I mean, whether one can net off in policy terms the negatives against the positives is quite interesting. And finally, I don't think there is the luxury in policy terms of ignoring or postponing degradation. I mean, I think if one tried to do that as an ex-negotiator, you get completely hammered by the NGOs, because you'd be said to be introducing a perverse incentive to encourage forest degradation. So, the people involved in the negotiations don't have the luxury of scientific purity. They have to find answers to these numbers somehow. So I think it's extremely important to get a degradation number to add in to this. And also, if peat decay is associated with deforestation is not included, then it's important to get a number on that too. And I expect it will creep back up towards the IPC 17.4, although as somebody said, that would no longer be 17.4 of total current, because the emissions have been going up.
Thanks, Jim. Another one? Right across the way, please. All right, or go ahead, you've got the microphone, stay with it.
Yeah, I got the microphone, so I'll stand up and say, Mr. Wilkie, FAO, I'm the one responsible for the FRA data that Alessandro has used, or at least I was for the one for 2010. Very nice to see the presentations here and get the background for why the data was so different. Also nice to see that you come up with at least the same order of magnitude for deforestation. But if you can just go back to the slide with the differences at the regional level, I think they were quite disconcerting though. But I may have some answers for why some of them are different. So,
Briefly,
just to say, the FAO data come from countries. The FAO data are not on deforestation, they're on net forest loss. So countries are trying to take into account also what they're afforesting and reforesting in that. In particular, the afforestation is not so big in developing countries in the tropics, but there may be some. Matt Hansen's forest loss map is also including loss that are temporary, so temporarily on stock, that's not deforestation. So that might be why you have a higher area for some areas, for example, Southeast Asia, maybe caused by fire and having that coming down. It's clear to see that in Latin America, it's easy enough to come up with a figure that there is some consensus on. It's also because deforestation there is large scale, so it's fairly easy to detect from remote sensing, and these figures are also what we are getting from a global remote sensing survey of forest loss that is done by FAO is about to come out. We will be the first to tell you that the figures from Africa are very poor, they're very old, they're an overestimate of the loss, and the remote sensing survey that we're coming out with is clearly showing that. So Alessandra's figure for Africa can go down quite substantially. I do think that it's disconcerting to see that the figures on the carbon stocks in South and Southeast Asia are 3 times higher by the Windrock team than from the Woods Hole. So that's certainly an area that we should look at. And just finally to say that yes, we have something that's the same order of magnitude, but once you take all of these things into consideration, I don't think you will come up with the exact same figure. We wouldn't expect that either. But it does also call for the need to get much better national monitoring systems set in place, particularly in Africa, something that's being worked on now, but there's a need for much better data in many of the countries that we're still talking about.
Thank you. I fear we need to stop with questions, friends, given the time boundary that we have. So let me come back to the panel. Maybe Jim's question about the negatives on this?
To the legacy?
Yeah.
I think I can try to address that. So very quickly, the legacy, yes, is not only from the industrial harvesting, but we have legacy also on the soils. So that is another element. And I also would like to point out that in both studies we didn't include peatlands. The peatland came up a couple of times, but both studies until now didn't include the emissions from the peatland.
And of course, also, when you cut a tree, a certain amount of that tree goes into dead wood, and so there's a profile for how wood decomposes in the forest. So there's all these different profiles, and so they take time. So it depends on what the decomposition coefficient has applied. I think on the soil, they might tend to use the 20 years, legacy. And then, of course, obviously, whereas the difference is we use committed emissions. Everything is just emitted at the time a hectare of land is cleared, is the way we simply did it.
Yeah. Not just dead wood, but also wood products. Some of the carbon may end up in wood products that decay or are retired through time.
Great, thanks. I'm afraid, Dan, can we?
On Meta's comment, by the way, we understand all those points you raised about what the data. My understanding is that SKI tries to pull out the gross number, he does it, he tries to pull it out with the plantations. That's the way, but the best he can do. We understand that it is net, and that's a bit of an issue. We fully recognize that. But I just wanted to say that, just because he does try to take that into consideration with the data. I mean, he does use more than just the FARA. He uses other sources as well.
All right.
This project is also not over, and so some of the differences that you pointed out we're constantly talking about and working on. So there will be some sort of more technical paper in addition to this policy brief.
Yeah. And just last comment about this big difference in Asia. We did start to investigate that, and right now what we see, for example, as a potential effect on this is that in our work we include all above ground woody live vegetation, while in the Harris et al. The biomass average is constrained to the deforestation, to the forest. So in our estimate, when we compute the average, we include also something that is not forest but are shrubs, right? And so, for example, India has a lot of sort of agriculture with shrubs and so on. So that brings down significantly the mean. But this is all under investigation. So we will also.
Thanks, Ali. Dan, can we turn to you as our kind of rapporteur for a last few reflections, given the questions we've heard and the discussion on the panel and the work conducted?
Yeah, 4 points. The first is that this, obviously, as you've heard from this group, this is a kind of point in the development of work in this area. Very encouraged to hear about the new developments of work by FAO that's going to further take us down the road on this. I'd posit that the experience is hearing all of your reflections on this panel has been a very positive one of bringing these groups together to resolve issues. And I think it's an interesting model to take this work forward. As new major work gets done, for example, the work that FAO puts out, it would be really helpful in this space to kind of accelerate the process of shared understanding of how this does or doesn't change the input to the policymaking community from other groups. So I would encourage that more attention go forward on communication within the scientific community that gets down to a deeper level than just reading each other's papers and responding to them. I reflected as we were in this process that these two groups now actually have the kind of depth of understanding of one another's methods that are usually reserved for what you understand about what's going on in your own lab. And it's to the extent that that can be a goal within this broader community, I think we'll be better off in terms of the utility of connecting the science to policymaking. So that's the first point. Second point is, it's come up a little bit, I've realized my own learning in this process is that some of the confusion is institutionalized. It's institutionalized because we have, through this history that Sandra began to describe, there have evolved a set of ways of kind of looking at this issue through different lenses that use the term, that throw around the term deforestation as kind of a shorthand. And so as Jim rightly pointed out, the IPCC assessment, one part of this, which really doesn't focus on deforestation as a number, but rather on net land use emissions. But sometimes when people write about it, they write deforestation, and it becomes a confusing area. FAO has its own kind of legacy of the institutional approach to this, which has to do with forest cover issues and net loss of forest cover, and that's another approach. And then the IPCC good practice guidance now looks at things differently through a lens of, well, deforestation, that's this forest converted to other lands. And so we've got, and that's the approach that's most analogous to the Harris et al. Work. So those different approaches are institutionalized. What we need is to, in our messaging, as was referenced earlier, we need to be really clear about what we're talking about when we use the term deforestation. Gross, net, net emissions, gross emissions, this is an area that gets easily misunderstood and confused. Okay, the third point that I wanted to make picks up on this question about percent and percent of what and so on. When you grab a copy of this brief in the back, you'll see that when the authors take a look beyond the work that they focused on kind of the best approximations for these other areas around land use emissions, I think the number that they have is 5.3 gigatons that adds up at 2.3 added on to this 3. And so that is actually rather close to the IPCC number. It does get you, again, depending on whether you're dividing it by the total or dividing it by fossil fuel emissions, we're in the same range of about 15% of emissions globally coming from that. So I think that's an important message to carry away. And
Press on, last point.
what's that? Oh, okay, sure. The last point, and related to this, is first of all that 5.3 doesn't include the plus, right? So what we're talking about are these 2 Ds plus peat, and we have REDD+, and we should be getting some mitigation out of that plus as well. And that brings me to my final point. As I said at the introduction, that this global benchmark is really important. Now, a lot of the targeting has been set vaguely at cutting deforestation in half. If we're going to actually, I think, realize the potential to mitigate climate change through reducing land use emissions, and we're going to have this really contribute optimally to the need that's there for bridging the emissions gap, we've got to do more than that. It's got to be more than that. Brazil has already demonstrated that the ability to cut emissions from the Amazon by way more than that. There's certainly opportunities in places like Indonesia to do that and more. And if we're serious about the contribution of REDD+, we have to set goals that are more ambitious, benchmark them, follow the progress, and address them going forward. Thank you.
Thanks, Dan. Okay. All of you, thank you for spending your late afternoon of Forest Day with us. We greatly appreciate it.